So in your booklet, you are looking for wherever we left off last, which is right here. So this is what we finished doing yesterday towards the end of class. So we looked at simplifying radicals. Okay, so simplifying radicals question is actually only worth 2 marks. So you're going to get one of these worth 1 mark and one of these worth another mark. So simplifying radicals is actually only worth 2 marks of the entire 85. So you may be thinking, well, whatever, I don't need this. This is not a hill for me to die on. Yes, it is. Because add, subtract, and multiply all require you to do simplify in the work. So this concept is necessary in order to be able to do the rest of the radicals concepts. Okay, so it's built in. That's why I only made it worth 2 marks, because the next question's worth 15, because you're going to have to do this a part of the others. Now, whether or not you choose to do stacking or whether or not you choose to do perfect squares, that is your choice. I could care less which one you do. I would say most 20-1 kids tend to switch over to the perfect square way, whereas most 20-2 kids tend to go with the stacking way. But every year we have kids that buck that trend. As long as you can get it down to the correct number, I don't care what method you do. Some kids will do it in their heads, they won't show any work at all. Whatever. Like you have to do what you want to do. But at the end of the day, you do need to know how to simplify because it's going to be part of the bigger question. And so if you screw this up, everything else you do will also be wrong. Okay? So we're going to start with adding and subtracting. So this is just in this booklet. Okay, so this is the booklet we started yesterday. You want to flip 1, 2, like 3 pages in. So the back of the second page is where we're at. Yep. Why? You just had a 10-minute break. Do you really? Oh. Okay, so the tricky bit with radicals is that each operation has its own set of rules. So there's a set of rules for adding and subtracting, there's a set of rules for multiplying, a set of rules for dividing, a set of rules for equations, and a set of rules for problem solving. The tricky bit is you have to memorize which rules to use with which questions. And because it's a very fast unit in 20-1, you have to learn it very quickly. That's the message of all things in 20-1. You get 1 day per concept. You have to absorb it that day, get it sunk in your brain, because the next day you're going on to something new. Whereas 20-2, there's way more work time involved. Okay. So the rule for adding and subtracting is if the radicands are the same, then you can add and subtract the coefficients. Radicands are the number underneath. Coefficients are the number in front. So on this first one, do you have the same radicand? Yes. So all you do for adding and subtracting is you just rewrite out the radicand. You don't actually add or subtract the radicand, you just leave it alone. What you're adding and subtracting is the number in front. What's 5 subtract 2? 3. And there's your answer. Now, everything can be checked on your calculator. So if we go 5 root 7 minus 2 root 7, so 5 root 7, subtract 2 root 7, and if we punch our answer in, the decimals will match. So this section of the final, which is worth 15 marks, you should know if you're getting 15 out of 15. Because if the decimals don't match, you know you've made a mistake. Now, knowing the mistake and fixing the mistake, those are 2 different things. But at least you will know that there's something to fix. Okay? Okay, so what if we add on an extra term? It doesn't matter. I can put 20 terms on the page. All you care about is the radicands. So do you have the same radicand? Yes. Now, when there's no number in front of the radicand, what can we assume it equals? 1. Did somebody just say 2? Okay, it's 1. Okay, so what is 4? Take away 9 plus 1. Not 2. So negative 4 root 11. Okay? So again, you could punch that thing into your calculator, punch in your answer, decimals will match. Okay? So what if you don't have matching radicands? Well, then you pair them up whatever you can. So here, I have a set of root 2's. And then here, I have a set of root 3's. So you do them as their own little mini questions. So what is negative 3 root 2 plus 4 root 2? 1 root 2. And again, you don't have to put the 1 there unless you want to. What is 6 root 3 minus 9 root 3? Negative 3 root 3. And you are done. Okay? So when the radicands are already written in their simplest form, it's just a matter of collecting what you need. However, for the most part, they are not going to be written in their simplified form. So this is what I'm talking about in terms of you have to know how to simplify in order to be able to add, subtract. So if you look at this and go radicand 125, radicand 5. If you punch this on, if you write this on your page, it's an automatic 0. You are not allowed to just subtract radicands. Okay? You can, what you're adding and subtracting are the numbers in front. You leave the radicands alone. So in this case, right now, I cannot do this question because my radicands are not the same. So what I have to do is I have to simplify first. So this is where what we were doing yesterday comes to play. So you can take that 125 and you can take it down by stacking, or you can take the 125 and do the perfect square. Okay. So for those of you who like to do stacking, what number would you divide 125 by? 5. And then what would you divide 25 by? 5. And then again, you've got twins and singles. So you've got a twin set, and you've got a single. So the twins and the singles. Okay, so the twins, you got 2 5s, and then the single, you've got 1 5. The reason why we're separating into twins and singles is because the twins always cancel off. So squares and square roots always cancel off. So I'm left with 5 root 5. Now, when we did this the first time, a whole bunch of you realized, hang on, the twins are always going to cancel off, and the singles are always going to stay in the house. So what a lot of you started doing is you started skipping this step. So you realized this single will always stay in the house. And this twin will always cancel down. So if you have a twin set of 5s, that becomes 1 5 on the outside. A single of 5 stays in the house. So a lot of you started skipping this. And that's great. When you can skip steps and still get out the right answer, fantastic. If you start skipping steps and make mistakes, stop skipping steps. Right? Definition of insanity is doing the same thing again and again and expecting different results. Okay. For perfect squares, what is the biggest perfect square that goes into 125? 25. And if you punch into your calculator 125 divided by 25, you get out 5. What is the square root of 25? 5. And then you just bring that down. So notice we get out 5 root 5 regardless, right? Doesn't matter which way you do it. If you're going to do the perfect square way, I would strongly encourage that when you get to the radical sections, when you get to question number 7 and 8, if you're going to do the perfect square way, write the perfect squares across the top of your page. So remember, you're going to count and square. So 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6. You're going to write that across the top of your page so that it's easy for you to figure out that biggest perfect square. And that's the other thing. It has to be the biggest, not just any perfect square. So what I've now got is 125 is 5 root 5 minus 1 root 5. Now do I have the same radicand? Yes. So what's 5 root 5 minus 1 root 5? 4 root 5. Now again, you can absolutely plug this into your calculator and make sure that you have done it right. So I can go 125 subtract root 5. And I can punch my answer in. Decimals match. Okay? So there's absolutely, I strongly encourage you to take that 10 seconds to punch each answer in to make sure that they match. Okay? Okay, so a couple more of add subtract, and then we'll move on to multiply. So right now, can I subtract the 80 and the 20? No, because the radicands are not the same. So adding and subtracting, the first thing that you do is simplify. So you don't even get to add subtract until you have simplified. Okay? So simplify comes first. So you pick your method. You're either going to take down the 80 and 20 by stacking, or you're going to take them down by doing the perfect square. Okay, so I'll do it both ways. You're only doing one. So this is going to take me just a little minute here. So if you're doing stacking, okay, 80 is even, so what does it make sense to start with? 2. Could I start with 10? If I wanted to go 80 divided by 10 as a starting point, can I do that? Why not? It's not prime. When you're doing stacking, you can only use prime numbers. So 2, 3, 5, 7, 11, all that. So 2 goes in 40 times, 2 goes in 20, 2 goes in 10, 2 goes in 5. For 20, 2 goes in 10, 2 goes in 5. You will get very fast at stacking. Okay? You will. Just, okay? Okay. Twin, twin, single. For the other one, twin, single. So what do we know? We know the single stays in the house. We know the single stays in the house. So this twin becomes a 2 on the outside. This twin becomes a 2 on the outside. This twin becomes a 2 on the outside. Okay? So this one will be 4 root 5. This one is 2 root 5. Perfect squares. What is the biggest perfect square that goes into 80? 16. And it goes in 5 times. What is the square root of 16? 4. Notice 4 root 5, 4 root 5. Same answer. What is the biggest perfect square that divides into 20? 4. What's the square root of 4? 2. Notice 2 root 5, 2 root 5. There is a subtract sign between them. Now do you have the same radicand? Yep. What is 4 take away 2? 2. So 2 root 5 is the answer. Okay, just do a quick hands up for me so I know who I'm talking to. Who is doing stacking? Okay, who's doing perfect squares? Okay, makes sense. Okay. Okay, so again, you could punch this into your calculator exactly as it's written. You would punch this into your calculator and the decimals will match. Okay, your page should not look as cluttered as mine because you're only doing one way, right? I'm just doing both. Okay, this question here is the most wrong done question. It is most done wrong, not because you don't know how to do stacking or perfect squares. It is most done wrong because you forget that you have a 7 and a 3 and a 2 already in front. Okay? So I don't care how you have to draw attention to that. Maybe you bring a highlighter into the test and you highlight the 7, the 3, and the 2. Maybe you put a little bubble around it with your pen or pencil. Maybe you put a box around it with your red pen and then the rest is all in pencil. But that was the number one thing you guys did wrong is you forgot to include the 7, 3, and 2 into your work. So for those of you who are doing stacking, you're going to have the 27, the 75, and the 147. So none of those are even, so you cannot start off with 2. So what would you start off with 27? 3, and then 3 goes in. So there's your single, there's your twin. What would you use for 75? 5. So there's your single, there's your twin. For 147, I'm going to actually go with 7. So 7s are your twins and a single of 3. So I'm not going to finish that off. I'm just going to swap over to perfect squares. Perfect squares, you would go 9 times 3. 9 is the biggest perfect square. 75 is 25 times 3. 25 is your biggest perfect square. And 147 is 49 times 3. 49 is your biggest perfect square. Okay? But again, it has to be the biggest perfect square. Has to. Okay, so back to stackers. You've got this root 3. That is your single all the way across. So you've got a twin of 3. So that means you put a 3 on the outside. You've got a twin of 5. So you put a 5 on the outside. You've got a twin of 7. So a 7 goes on the outside. And then here is where the wheels came off. You already have these numbers in front. So you have to go in and include them back into the front. So you've got 7 times 3 is 21. 3 times 5 is 15. And 2 times 7 is 14. You have to go back and include that highlighted number. Now, if you're doing perfect squares, it's nice because you've got it all written together. So you would have, I'm just going to do it down here. You've got the 7, square root of 9 is 3, and the root 3 stays. You've got the 3, square root of 25 is 5, and the 3 stays. You've got the 2, square root of 49 is 7, and the 3 stays. So notice it's the exact same thing that I have there. Okay, it's just how you're organizing the work. So I've got 21 root 3 minus 15 root 3 plus 14 root 3. They all have the same radicand, so that's 20 root 3 as a final. Now, we're stopping here. So if you're coming into 20-2, that will be your peaking out point. In 20-1, you would keep going. So what would happen in 20-1? Well, in 20-1, maybe the radicands were 2,700, 750, and 1,470. So they would make the numbers bigger. Or maybe the numbers in front would be 7 halves, 3 fifths, and 2 fourths. Right, so it just means that when you're doing this, you're probably going to have fractions here, and then you just use your calculator instead of your brain. But the process doesn't change. We're just trying to make your life more difficult. That is literally like Math 21, here to make your life more difficult. Like that is the slogan of the course. Because at the end of the day, that's the math. Everything else is just nasty tasting frosting that does nobody any good. Except gets you into 30-1, which is a whole nother headache in and of itself. Okay, if 20-1 doesn't make you cry, 30-1 will. So there's that. Okay, so keep in mind this question. So unlike factoring, where I could care less about your work, I was simply marking brackets. Radicals, all I care about is your effort. So in radicals, I am marking your work. I am marking the answer, but you get lots more marks for your process. Now, couple mistakes. I didn't make any on this one, but I did make one in the last class. In the last class, you see how my little radical sign kind of comes up like that? In the last class, I wrote my 21 too small, so it looked like it was 2 root 3, not 21 root 3. So I missed the 1. I missed the 21. I just thought it was a 2. Which brings me to what I've talked to you about before, is penmanship. I'm not talking about having beautiful handwriting. I'm talking about writing it neat enough on your page so you can actually read what you just wrote. That's what I'm talking about. Okay? That is the number one mistake, is you literally can't read your own writing. The other mistake, and there was a bunch of you that did this, instead of going 7 times 3, you went 7 plus 3, and you wrote 10 here. And then here you went 3 plus 5 instead of 3 times 5. Here you went 2 plus 7 instead of 2 times 7. So you added when you should have been multiplying. Okay? But again, if you punch this into your calculator, and if you punch this into your calculator, if it doesn't match, you know you have screwed up. Okay, so at least you know you've got to go back and see what on earth you did and try to find that mistake. I'm betting most of you will have forgotten about the 7, the 3, and the 2. That is usually the mistake kids make on this. Okay, so that is the hardest thing I'm going to ask you on your final. Nothing harder than that. Okay, multiply. I'm missing a page here. There we go. Got out of order. Okay, multiply. So multiply, you do not need the same radicands. So what happens with multiply is the same as polynomials. We multiply the numbers. That's it. So here I have 2 monomials. So all I'm going to do is multiply, multiply. Okay? You're not done. Once you have multiplied, then you check. So the add subtract rule is you simplify first, then you add subtract. With multiply, you multiply first, then you check for simplify. It is the exact opposite. Add subtract, the simplify comes first. Multiply, the simplify comes second. Okay, so every operation has its own rule set. And that's the tricky part with radicals. The math, once you get going, is fine. It's just remembering what rules are for which operations. So for 30, I'm just going to do a stack. So 2 goes in 15 times. 3 goes in 5. Did I end up with any twins? No. So since there's no twins, this is actually as simplified as it gets. There's nothing else I can do. Just because a number is big doesn't mean it can go down. No, it's only integers. What they're going to huck at you in 20-1 is put letters in there so that it's not always numbers. So then you're going to have to use exponent laws to simplify them down. Okay. Okay, don't worry about the fact that there's a negative here. Again, do the same thing. So negative 2 times 5, 8 times 12. Now again, if you leave it like that, you're just not going to get full marks because you haven't simplified it down. Yes, you did the multiply, but now you need to keep going. So I don't care if you do a stack or a perfect square. Okay, it's up to you. I'm going to divide it by 2. And keep dividing by 2 until I can't anymore. Ooh, lots of 2's. Okay. So I've got a twin. I've got another twin. and I've got two singles. So first twin comes out of the house. Next twin comes out of the house. Singles stay in the house. Everything gets times. So 4 root 6. If you're doing a perfect square, it would be 16 times 6. So the biggest perfect square that goes into 96 is 16. Now again, you've got this negative 10 in front. So you've got negative 10 times 4 root 6. So the answer is negative 40 root 6. Now again, you can check this on your calculator. Exact same way we did add subtract. So negative 2 root 8 times, what was it, 5 root 12? And then my answer was negative root 6. Okay, exact same answer. So it doesn't matter what operation you're doing, you're more than welcome to check. Now, do not write that decimal anywhere on your page. You will not get any credit for it. We are doing an algebraic simplify of these radicals. I don't care what their decimal value is. I will care when we get into solving equations in grade 11, but I do not care about it right now in grade 10. Okay, let's up the ante one. So now we have a monomial times a polynomial. So we're going to do these, yep, the exact same way, yep, that we did in grade 10 and grade 9. When you have a monomial anything, you just distribute through the bracket. So again, multiply first, simplify second. I'm going to put my ones in just because I find that a little bit easier. You don't have to, but I just find that's easier to think about. So 1 times 2, 5 times 10. 1 times negative 1, 5 times 5. So multiply first. Now we check for simplifying. So for the 50, so 5 goes in, 5 goes in. There's your twin. There's your single. If you're doing perfect squares, it would be 25 times 2. Okay, so the twin comes out. The single stays in the house. Don't forget you got this 2 here in front. So you got the 2. The twin comes out. Or you can think of it as square root 25. And then the 2 stays in the house. Now, for the other one. Shh, guys. What is the square root of 25? So it's just minus 5. Not root 5, just 5, because the square root of 25 is 5. So my final answer is 10 root 2, subtract 5. These will not all go down to a singular term. Simplify just means do something mathematical. It does not mean get the answer down to like 12. Okay, that is a number. I have no idea what the number is, but it's some nasty looking decimal. That's all I care about. I have expanded by multiply, then I have simplified it down the best way I can. Okay, so for the next one, so 2 times 3, 5 times 45, 2 times 8, 5 times 5, 2 times 3, 5 times 20. Again, multiply first. Gentlemen, those phones need to go away. Okay, something kind of interesting happens here. What do you notice about all the radicands? What are they all? They are all perfect squares. So we don't need to do any stacking on this at all. We can just take it straight down. Now, if you don't know your perfect squares, use your calculator. Okay. What is the square root of 225? So 6 times 15. What is the square root of 225? What is the square root of 100? Now you can punch it into your calculator. You can go 6 times 15, subtract 16 times 5, plus 6 times 10. I have no idea. I don't want to bother punching in. 70? Works for me. So, when you have plain old radicands, you take them down. When you have perfect squares, you take them down. Everything has to be simplified, regardless if it's nice looking or not so nice looking. Okay? For those of you going into 20-1, you will have less and less perfect squares and more nasty looking radicands. Okay? Now again, just so you are aware, this is the first unit of 20-1. Meaning of the 10 units, they get successively harder after this. So if you're already feeling kind of peaked out, do not go to 20-1 because it's just going to get, this is unit 1 and it builds from there. In 20-2, we have 2 big algebra units. This is one of them. So this is something we build to in 20-2. The other units are easier. Okay. Okay, 2 more. Binomial times binomial. So if you're looking for the area of something, that is length times width. So when you have a binomial times a binomial, your choices are tic-tac-toe, distribution, and FOIL. Those are your choices. So you're going to do this the exact same way we did yesterday with multiplying. That nothing changes. Just instead of having the letter X, you're going to have a radicand sign instead. Okay, so if tic-tac-toe worked for you yesterday, you're going to do tic-tac-toe again today. If FOIL worked for you yesterday, do FOIL again today. Okay. So I'm going to show you both ways. Now, I like to put the ones in. You're not required to do that. So if you're doing tic-tac-toe, everything gets its own box, and you're going to multiply. If you're doing distribution, separate up the first bracket, leave the second bracket together. If you're doing FOIL, what you're going to do is you're going to put your finger over the one term, and you're going to multiply. And you're going to put those two answers right here. Then you're going to put your finger over the other one, and you're going to multiply. And those two answers go right beside. So you do it the exact same way. So multiply first, then we'll get into simplify. So you are only writing down the way that you like. Do not write down everything I'm putting down. Okay, you're only writing down what you prefer. So you're multiplying. 7 times 4 is 28. 7 times 1, stick the root 6 on the end. So 7 times 4, 7 times 1. Next one, 4 times negative 1, stick the root 6 on the end. Positive 1 times negative 1 is negative 1. 6 times 6 is 36. Negative 1 times 4, stick the root 6 on. Negative 1 times positive 1, 6 times 6. Same 4 terms, just one's in a box, the other one's a line. It's exactly the same as multiplying, what we did yesterday. Now, just like yesterday, we looked for like terms. Here you have the same radicands. Here you have the same radicands. So, let's do the add subtract first. We're going to do this in steps. So we got the 28. When you've got the same radicand, we can add. What's 7 minus 4? Or 7 plus negative 4? 3. And then you got the root 6 there. Now we've got this minus 1 root 36. So that's the first simplify that we can do. We can do add subtract. Is there any more simplifying I can do? What's 36? It's a perfect square. What's the square root of 36? 6. So I've got 28 plus 3 root 6 minus 6. So my final answer is 22 plus 3 root 6. Now, this one question, I could just make the operations on radicals section of the final. I could just ask this one question and call it good. I could just make that section worth 4 marks instead of 15. Because on this board covers everything that we have talked about. We have talked about multiplying. We've talked about adding and subtracting. We've talked about simplifying. Multiply, add, subtract, simplify. One question covers everything in the radicals unit. Now, I'm not going to do that because it's a hard question because it contains everything that we've talked about. But that's what makes the multiplying questions such good questions, is because it covers everything in a unit in just one fell swoop. So again, we're not just marking answers, we are marking the process that you take to get there. Okay, one more. When you see a squared, what's the first thing you do? Whether you're doing polynomials or radicals, what do you do first? When you see a squared, you write it out twice. Now you have your binomial times binomial. Okay, I'm going to go quiet. I am just going to put the answers up here. Do not look up unless you need help. So you decide if you're going to do tic-tac-toe, distribution, or FOIL. Only look up if you need help. But let's see if you can get out the right answer without any extra help from me. Okay, if you get the same answer as me, you are more than welcome to take your break. If not, stick with it until you get it to work. Watch the cord. Okay, so if we go back and look at this question, so again, once you've got the multiplying done, that is just step one. You still have to go through now and do all the simplifying. So you've got a negative 12 root 6 and another 12 root 6. So that gives you the negative 24 root 6. Okay, so that's the add subtract. Then you have to look at your radicands. So 9 and 4 are both perfect squares. So the square root of 9 is 3. So 9 times 3 is 27. The square root of 4 is 2. 16 times 2 is 32. So you've got 27 plus 32, which is your 59. And then you've got the negative 24 root 6 on the end. So that is the hardest we're going to huck at you on this exam. If you're going into 20-2, that would be the most difficult multiplying question you would get. 20-1 is a little bit harder. One sec. Okay. Questions on that? Okay. So for today, in your homework booklet, you can work on any of these sections. So A is multiplying, B is factoring, H is simplifying radicals, I is add subtract, and J is multiply. So I suggest you pick a section and start. Okay. I and J together are worth 15 marks. Section B is worth 12 marks. The other two are worth less. So if you're going to put energy into a section, you want to make it the biggest bang for your buck. That would be B, I, and J. Okay? So you've got about 40 minutes left today. You got a good chunk of time to work on this. I suggest you put in the time to do some of that work because you really didn't have any time yesterday at all. But again, if you use the practice time every single day, you will have very, very little that you will have to do the night before the test. If anything, if you use the work time this week and next week, all you'll have to do on Tuesday night is just go back through and look at your notes, look at the work you have done, and go, yep, I'm ready to go. I understand everything, and off you come in. Okay? You shouldn't have to do any more actual written practice. Okay? So pick a section to work on, please. That is what you're working on today.